Okay, hello. I'm in part 2 of my coding challenge where I am attempting to evolve a vehicle triangle thing to eat some green dots and avoid some red dots because I don't know, that's what my life has become. It's kind of interesting though. I'm having a good time. Okay, so where did I last leave off? So right now I have a vehicle that just is attracted to red and green and goes to whatever it's nearest to. But there is actually a big issue. It's going to have an error every once in a while because one thing that I'm doing here, I'm surprised that I haven't had a problem yet, is that, oh, I already fixed it. No, I didn't fix it. This could happen where I delete a certain element from the list and then I seek it afterwards. So what I really need to do is, if I'm about to eat that dot, I don't need to seek it anymore. So I only either want to eat it or seek it. And because if I'm eating it and deleting it, it might not even be there for me to seek anymore. And then also, to be honest, it's technically possible that there could be no dots and closest could be number 1. So I should also just could be -1, could be an invalid index. So I should also really just check and say, also let me make sure that closest is not equal to -1. Or maybe I could just say is greater than -1 is fine too. So this is really a bit more error protection here. And this might change later because I'm thinking about how I'm going to keep going with this. But right now, I should either eat and delete it or seek it as long as it actually exists. And so now this should run without any errors. And what I might do just to kind of test this out is, just to be sure, let me not add any poison. And, whoops. I probably should, I think a good way to just quickly test this is let me not add any poison and let me add 100 pieces of food, and let me just run this and we're going to see very quickly. I shouldn't have any errors. I suppose there could be an error when it gets to the last one. So let me just add 2 pieces of food. 1, 2. Okay, we're good. So now we are good. This code is working. We can keep moving on. So now here's the thing. Let me add 10 pieces of food, 10 pieces of poison, and here we are again. Now, here's the thing. For me, one of the magical things about working with steering behaviors, and this is really where your creative outcomes could come from, is that there can be multiple factors at play. This is a very primitive demonstration of that. There are 2 factors at play. My level of attraction to green dots, my level of attraction to red dots. That level of attraction could be weighted. It could be positive, it could be negative, and those things could change over time, and they could be different for different vehicles. So what I need to add to this, and I'm going to try to evolve the appropriate weights for those 2 forces, but what I need to add to this is that weighting. So let's figure out how we're going to do this. And my concept here is that those weights are going to be the object's DNA. It's genetic information. So I'm going to add a variable called this.dna, and I'm going to make that an array. And this is a little bit iffy here, but let's do this. I'm going to say this.dna index 0 is a random number between -5 and 5. And this.dna index 1 is a random number between -5 and 5. Okay? I'm feeling good about this. So now the idea here is, the other thing that I really think that I need to do is, I think what I want, so there's something that's a bit awkward here, is that, it's not awkward, but I think an improvement that I need to make on this is that I really should just use, let's use another function. This might not be unnecessary, but this might not be necessary, but I'm going to, I'm going to say apply, I'm just going to call this behaviors. I don't like what I'm doing. I have to think about this for a second. Do I really want another function? I'll talk this through for a second. Because what I could do is I could apply the weight right here. I kind of like the idea of having a separate function, and this just returns the steering force, and then I'm going to do the weight somewhere else. That's what I'm going to do. This might not be necessary, but I'm going to write another function called behaviors. And the idea here, let me just sort of sketch this out, is I'm going to say this dot food steer, I'm going to call it food steer equals something. Oh, no, there's no this, sorry. Var food steer equals something. Var poison steer equals something. I want to get what's the steering force for food and poison. Then I want to say food steer dot multiply this dot DNA 0. Poison steer dot multiply this dot DNA index 1. So the idea, and then I want to say this dot apply force food steer. And that should say apply. Can you see that code? Yes, you can. And this dot apply force poison steer. The idea here is, and again, I don't necessarily need a whole separate function for this, but this to me is the magic of working with steering behaviors. Imagine if the thing that you invent is so much more complex that there are all these different forces at play in the system that it could cause it to do something at any given moment, and they're all weighted differently. So I want a function where I calculate all the different steering forces, I weight all of them, and then I apply all of them. I can sort of see it in one place. So what goes here? Well, honestly, what I want to do is I want that to be this dot eat the food, and this dot eat the poison. And I'm going to zoom back out here. So I need to change the way the eat function works to return the appropriate vector, the appropriate force, rather than use it there. But and now I really probably should, honestly. You know what I'm going to do? I'm going to say good, bad. I'm going to give this arguments, good, bad. And then I could also say, it's fine. I'm going to say steer G, steer B. I'm just going to make this more generic, just to make these variable names different. So because you could imagine having different lists doing different things. OK, so now that I have this, that would change the main code to say instead here vehicle behaviors food comma poison. The idea is there's one function. It gets the food and the poison, and it does the stuff in it. So let's go refactoring here. So now the eat function here should say return this dot seek. So what I want to do is I want to return the vector that comes out of seeking. Now the seek function doesn't do that. So, if it finds something that it should seek, return it. If it doesn't, I'm just going to say, this is rather inefficient, but I'm just going to say return a 0 vector. So if it's seeking something, return that. Otherwise, return a 0 vector. Right? If there's no food, there's no poison, 0 vector. OK. Now, this function now should, instead of applying the force, just return the steering force. So I've altered this. Again, I'm sure if I thought about this even more, or you probably have your own idea of a different way of organizing this, but there's this kind of chaining happening here. The first thing that happens is this behaviors function gets called. Then I say, eat this good stuff. And what that function does is it runs through this eat algorithm and returns the result of a vector that's calculated from the steering force for the closest thing. So eat behaviors triggers eat twice, and eat triggers seek. And then what's returned from seek comes back to eat and gets returned back up here. OK? So now if I run this, and let's just make the weights, let's make the DNA just for the sake of argument right now, 1, 1. So I should see now that, error, poison is not defined, sketch line 37, because I like to spell poison wrong apparently all the time. Poisson, poison, fish. OK, so now we should see that it's the same thing I was doing before. However, now if I were to go into the vehicle and say -1, we should see that it is attracted to. Let's see, this is not optimal. It's kind of working, but it could be that it's so repelled. Right now, it's so repelled by by the poison that it might not be able to actually find a green thing. So I'm going to evolve it to work out all this stuff pretty well. But I think we're in kind of good shape here. I want to make this a little bit bigger so we can easier to sort of look at and track it. OK, now let's go back to doing this, 5, -5. Let's run it again. So I don't know what weights it has. Oh no, that's actually, no, I do know what it has. Let's make it random. That's what I meant to do. So one thing that I think would be useful is to visualize those weights so that I have an understanding of what it thinks it's doing. You can see right now it's eating all the red stuff. OK, here we are. So what I want to add now is I want to visualize those weights so we can see what's going on. So I'm going to go just to this shouldn't be too hard of a thing to do because I have this nice display function already. And the display function is drawing this triangle, and it's rotating the triangle based on an angle in the direction that it's moving. So what I want to do, let's just see what happens if right here, if I add, after the triangle is drawn, if I add a line from 0, 0, 100, 0, 100, 0, and I say stroke 255. Oh, OK, so you can see there's a line pointing out to the right. So I want the line to point out to the front. So I'll say from 0, 0 to 0, 100. Now, it's pointing out to the back, but that's fine. So what I want to do is actually have this DNA index 0 dot, DNA index 0 times, let's just multiply it by 10, so it'll be between 0 and 50 long. And then I want to draw another one, index 1. And this, if it's, I have it in reverse, I guess, for whatever reason. So if it's positive, it should be pointing to the front. So I should make this negative. And so this one, DNA 0 is for green dots. And DNA index 1 is for red dots. So now we should see visually, OK, this dot DNA, this dot DNA. Let's run this again. OK, so we can see here, and maybe if I do this randomly a bunch of times, maybe between, I should multiply it by 20, so that's a bit bigger. And you know what I might actually do, in fact, is draw this before the triangle. So that might actually be a bit more effective. Whoa! And then now I should say stroke 255. Let's get the, or whatever this is. So let's try that. OK, so we can see, and we do this again. There we go. So now we can see this looks like one that's pretty optimal, right? It should be attracted to green and not attracted to red. But it didn't really do a very good job. So now we need to try to evolve this thing. We need to evolve what might be some optimal weights. What are some steps? OK, well, first of all, oh boy, let's add a few more things before we get to part 3. Number one is let's add a bunch of these vehicles. So let's go here to the main program. Instead of having a single variable called vehicle, I'm going to say vehicles equals an array. Then I'm going to say var I equals 0. I is less than 10, because I'm just making 10 of everything. Let's create vehicles. Index I is a new vehicle. And what I can also do is give the vehicles random locations to start at. So this should now, oh, and then here, what do I need to do? Here I need for this to go through and call these functions on all the vehicles. So this is a really quick thing, just to add an array. And we can get rid of this now and run this again. And what do I have? Vehicle is not defined, right? Because this should be vehicles index I, vehicles index I, vehicles index I. So I'm looping through and calling these functions on all of the vehicles. And we can see there's a whole bunch. And we can sort of say some of them are doing well, some of them are not doing well, that sort of thing. So now, let's add something else to this. I would like the vehicles. As I said earlier, the primary mechanic here is health. So as they eat the red dots, the green dots, they should increase their health. As they eat the poison dots, they should decrease their health. So let's now add that to the vehicles. So I'm going to add a variable. I'm going to call it, where are we? I'm going to say health. This dot health. I'm going to give them a health of 1. So I think it's going to be easiest for me to think about this as their health is some number between 0 and 1 always. So they have a health of 1. Every frame, let's just say their health goes down by a little bit. Let's just say, I don't know what's going to be a good number, but every time through update, they lose a little bit of health. Now, also, when they're eating, now here's a tricky thing. This is the moment here. This is the moment of eating. I'm looking over there to watch me type that. This is the moment of eating. But this is a generic function. How do I know if they're eating something good or bad? So many ways I could approach this. I don't know if I'm going to love this right now, but I'm going to say, I'm going to give this, actually, you know what? I'm going to love this. 1, -1. So when it eats something and it has kind of like, is that good or bad? And I'm actually just going to put, so every time it eats maybe a piece of good food, its health goes up by 0.1. And every time it eats some bad food, it's poison, its health goes down by -0.5. So let's make the poison really, really bad. So now what I could do here is say this dot health plus equals, and eat should have, I'm going to just call this argument nutrition, nutritional value. This dot health plus equals nutrition. So now, I mean, I don't know, we're not going to see anything different here, but in theory, they've got this health that's changing. But this is also something I really need to be able to visually see to understand what's going on. So how do I do that? One thing that I could do is right here, right? This is where I am setting the color of the what is this thing? Vehicle. So there's a function. Oh boy, this is exciting. There's a function in P5 and in processing called lerpColor. Lerp is a word that means linear interpolation. And just to diagram this for a second, if you could imagine red being over here and green being over here, you could imagine all the colors that exist in between red and green. And if I said maybe 0 means all the way red, 1 means all the way green, 0.5 means somewhere in the middle, 0.75 means over here, this is perfect. Because I have this health, when it's 0, it should be red. When it's green, when its health is 1, it should be fully green. So the lerpColor function, if I give it 2 colors and a percentage, it's going to give me that color somewhere in the middle. So I'm going to come over here, and I'm going to say var gr for green equals color 0 to, there's probably a better way for me to do this, but rd for red is color 25500. And now I'm going to say var the actual color is lerpColor between red and green and this dot health. So this should now give me a color in between. I could have put these directly in here. I'm just putting things in separate variables to make it more legible. But I am now giving myself a color somewhere between red and green. So now I'm going to say fill by the color, stroke by the color, and now I'm going to run this, and we should see they're all green. That one's red. Slowly over time, you can see how they're turning red as they eat the poison. There we go. Okay, so here's the thing. Let's just do one more thing before part 3. What I need to do is I need to say, like, well, what if its health goes all the way down to 0? I've got to eliminate it from the world. It's died, so to speak. So I'm going to write a function, this dot dead equals function, and I'm going to say return. I never write code like this, but I'm going to do it. This dot health is less than 0. What this means is this is a Boolean expression. I could say if this dot health is less than 0, return true. But I don't need to say that because this dot health less than 0 evaluates itself to true or false. So return the result of this Boolean expression. Is it less than 0, return true. If it's not less than 0, return false. Because less than 0, true, it's dead. And then what I'm going to do here in the sketch is I'm going to say, if vehicles index I dead, vehicles.splice I, comma 1. So this is me saying, if the vehicle's health has gone less than 0, delete it from the array. It's gone from the world. It shall live no more. A little bit of a problem here, which is, and I've talked about this in so many different coding challenges in various videos, but if I'm iterating through an array and taking things out of the array as I iterate through it, things start shifting around and I can skip stuff. So I've got a little bit of an issue here. One way to solve this problem is to go through the array backwards. I will try to remember in this video's description to link to a video where I actually go through this in detail. Why? And there's other solutions to this problem, but I'm going to just start at the end of the array, go all the way down to 0, and say I minus minus. And now let's watch this go. So we should see, does anyone survive? Everything died. Let's just do something. I'm going to do a couple things just to kind of make this look. I'm going to make the vehicles a little bit smaller. And I'm also going to add a great deal more food. I'm going to add 50 food and only 10 poison. And let's just see if any of them do particularly well and kind of live. Now, one thing is the food is going to run out. But you can see that one's doing pretty well. It died. OK. So we're close. Let's add one more thing. Let's add one more thing before part 3. Let's at least every so often add some more food. So I'm going to say if random1, if I pick a random number and it's less than 0.05, so 5% of the time, let's do the thing where I add a new piece of food. And I could put that in a separate function. So every so often, I'm going to add a new piece of food so that there's always new food for these things to eat. OK, come on. So you can see this one has survived. So this one, if I had some evolution, I'm excited for it. I'm like, go, go, eat all the food, don't die. Is it enough? So it might need for its health to go down a little bit less, or for the food to actually have a greater nutritional value. But you can see this, I think we need to tune this a little bit, but good enough for now. OK, so we're close. We've got this whole system now. We have a bunch of vehicles. They all get random weights, attraction or repulsion, and some of them seem to do better. But how could I really evolve over time to get the optimal weights? And I also need to I want to add another property to these vehicles to make the evolution a bit more interesting. And that property, which you could do, try to add this yourself, is how far away can it actually see a piece of food? What if it ignores food unless it's within a certain distance of sight, and it ignores poison unless it's within a certain distance of sight? And are there some optimal, I suspect, based on the fact that I've made something like this before, that we might see an interesting result there. So anyway, I'll be back in part 3. Try to see if you can add that. Add 2 more properties, which you can think of it as its perception. It's food perception and it's food perception and it's poison perception. And I'll see you in the next video where I actually add that myself, because that's what I'm going to do right now, except for you. I don't know if it's going to be right now or not or whatever, but OK, see you soon.